find the value of P for which the points are collinear. So what I'll do here is I'll put the expression for area of triangle equal to 0 because these points are collinear, so they will not form a triangle. Or in other words, we can say the area of triangle formed by these vertices is equal to 0. So what was the expression for area of triangle? Half into x1 y2 minus y3, that is p minus minus 1, so p plus 1, plus x2 y3 minus y1, so minus 1 minus 3, plus x3 y1 minus y2, so 3 minus p. I'll put this equal to 0 because these points are collinear, right? And this 1 by 2 doesn't matter, you can cancel it out because there is 0 on the right hand side, right? So what is the expression inside? It is minus p minus 1. This is minus 4 into 2 minus 8. This is 15 minus 5p. So 15 minus 5p, and it is equal to 0. So how many p's are there? Minus p minus 5p, so total minus 6p. And this is 15 minus 8, 7 minus 1, 6. So I'll have 6 here, right? So if I take it on right hand side, so it will become minus 6. So p will be equal to 1 for these 3 points to be collinear. Okay, I hope this question is clear to you. This was a simple application of the formula that we derived for area of a triangle, right? Now find the area of quadrilateral formed by joining these 4 points. So we know how to find the area of quadrilateral. We will write the points in this fashion: 1 1, 3 4, 5 minus 2, 4 minus 7, and then we will write 1 1 once again. Okay, now let me multiply it in this fashion: 1 into 4, and I'll keep it right here. So half into, this will be the area, half into, so 1 into 4, 4, 3 into 2, minus 6, 5 into minus 7, minus 35, 4 into 1 is 4, minus 3 into 1, 3, 5 into 4, 20, 4 into negative 2, minus 8, 1 into negative 7, minus 7. So what have we got? This is 1 by 2. This is 4 and 4, 8, minus 6, 2, minus 35, minus 33. From here I'll have, this is minus 8 minus 7, so minus 15, plus 5 plus 3, 8, so effectively it is minus 8. You can do your calculations yourself, right? So this is minus 41 and divided by 2. So this will be the area, but this is a negative number, so I'll put modulus, because this is how we calculate area. We put modulus outside so that even if we arrive at a negative number, the modulus will make it positive because the area cannot be negative. So the area, or your answer for this question, is 41 square units. This is 41 divided by 2 square units. This is the area of quadrilateral formed by these 4 points. Okay, so always keep in mind that you cannot have a negative area, so you make it positive by writing it inside a modulus sign. Find the area of pentagon whose vertices are given like this. So again we will apply the same method. Let me write the vertices in this fashion: 1 1, 7 21, 7 minus 3, 4 minus 7, 0 minus 3, and then I'll write 1 1 once again. Okay, so I'll write half and then start the bracket. So I'll multiply it like this first: 1 into 21, 21, 7 into minus 3, minus 21, 7 into minus 7, minus 49, this will give me minus 12, then I'll have 0. okay, minus. Now let me multiply in this way. 7 into 1, 7. 7 into 21, 147. 4 into negative 3, minus 12. 0 into something, 0. 1 into minus 3, minus 3. Okay. Now let me calculate. 21 gets cancelled. This is minus 12. This is minus 49. So collectively it can be written as minus 61, right? And here inside this bracket I have minus 12 minus 3, which makes it minus 15 plus 7, so it becomes minus 8. 147 minus 8 is 139, and then this negative sign, so minus 139. If you see inside the bracket, this is minus 139 minus 61, so it will become minus 200. So if you cancel it, it will become minus 100, and area cannot be negative, so I'll write 100 square units. So this is the area of pentagon formed by these vertices taken in order, right, as these are written. So it is important that when we are not talking about triangle, we write that the vertices are taken in order. Otherwise, it can be a different figure altogether. If the coordinates of two vertices of a square are a comma b and b comma a, find the area of square. This looks like a simple question. We are given the coordinates of opposite vertices like a comma b and b comma a, and we need to find the area of this square. So we know that if I have got a square, let us say I have got this side of square as a, so what will be the area of the square? It will be a square. But if I ask you what will be the diagonal of this square, you will say it will be equal to root 2a, right? How? Because you can apply Pythagoras theorem and find it out yourself that the diagonal is root 2a. So if I put root 2a equal to, let us say, d, so if I want to write this area in terms of this diagonal d, how will I write? So if I write simply d squared, so what will it be equal to? It will be equal to 2a square, right? So if I divide it by 2, now this is expression for area of square in terms of diagonal. Now I know that the diagonal here can be calculated by applying distance formula, which is difference of abscissa squared plus difference of ordinate squared square root. What is difference of abscissa? It is a minus b, square it. What is difference of ordinates? It is b minus a squared, or you can write it a minus b squared also, square root. So this is the length of diagonal, right? So what is the area? You can collectively write it as 2a minus b whole squared, right? So what is the area? It is square of this diagonal divided by 2. So this will give me root 2 squared is 2, a minus b whole squared divided by 2. So the area of the square is a minus b whole squared, right? If the coordinates of two opposite vertices of a square are given, then the area can be found very simply, because you can find the diagonal very easily by applying the distance formula, and then you can write the area in terms of its diagonal like this, right? So this was another question.